Okay, so the goal of this video is to introduce the shape, behavior, parent function, so to speak, of the secant and the cosecant graphs. And secant and cosecant graphs, I'm going to use their reciprocal function sine and cosine to help build their functions or build their graphs, just using the relationship that the reciprocal of cosecant would have been sine and the reciprocal of secant would have been cosine. So the first thing I'm going to do, and this is going to be true anytime you graph any kind of cosecant function, is you want to think it's reciprocal. So we're going to think sine of x. So remember, sine of x starts at equilibrium. At pi over 2 goes up to 1. At pi over equilibrium, negative, at 3 pi over 2 we're negative 1. And then at 2 pi we're back to 0. So we have this nice, very aesthetically pleasing graph, right? Same thing down here. So the reason I'm starting with that is because if I know that cosecant is the reciprocal of sine, then I'm going to take the reciprocal of all these values. And in particular, I'm going to know that I cannot take the reciprocal at 0. I cannot take the reciprocal here because I can't take the reciprocal of 0. I can't do 1 divided by 0. So when I try to do 1 divided by 0, when I'm trying to do 1 divided by 0 and I get does not exist, I know from last chapter that that's going to give us a vertical asymptote. Remember, 1 over 0 gives us a vertical asymptote. And if you have a really good memory, you'll remember 0 over 0 is a whole, but this is 1 over 0, so there's a vertical asymptote. So every time the sine function would have crossed the x-axis, that's where I know my vertical asymptotes exist. So I have these vertical asymptotes at 0, pi, 2 pi, right? Very good. Same thing in their negative counterparts, okay? And then all you're doing is taking the reciprocal. And so what ends up happening is all of the values that are less than 1, because if you think about the sine function is opposite over hypotenuse. And so all those values are less than 1 as you go around the unit circle. Then the reciprocals would be things that have to be greater than 1 divided by that fraction. So what ends up happening is we get these flipped over branches. So they look like U's that are bounded by vertical asymptotes. So this green peak and valley, so to speak, that's really the graph of this cosecant function. The asymptotes obviously serve as boundaries. And then I kind of like how the sine wave sort of dances in between those branches. And that sort of gives me what I like to call negative amplitude. So there's going to be a space in here, and they do touch, but there's space in here where cosecant doesn't exist, right? There's a void. And so cosecant really doesn't have amplitude because remember, amplitude is how high you are from the line of equilibrium. Instead, I call anti-amplitude, kind of like maybe anti-hero. All right, I don't know. Sorry, Taylor Swift connection. But when I talk about like the missing piece of cosecant, it's where sine would have been graphed between 1 and negative 1. Now, since sine and cosine are related, then the graph of secant and cosecant are going to also be very much related. So when I think about first graphing secant, I'm going to think cosine of x. Remember, cosine of x starts here, it's down to there, it's at negative 1 at pi, we're back at 0, and then back up to 1. So again, just draw dotted for cosine. And we're going to follow the same sort of pattern that we're going to find out where does the cosine graph cross the x-axis, right? And then wherever it crosses the x-axis, that's going to give rise to vertical asymptotes. Vertical asymptotes. So there'll be one at 3 pi over 2. There'll be one at, negative 3 pi over 2, negative pi over 2, and then pi over 2, and then 3 pi over 2. So I have these vertical asymptotes that I should probably do a good job at drawing these arrows, right? And then the actual graph will go in between those. And they do touch. They do touch right at that point. So it touches and goes right back up. And then it touches and goes right back down. I should make that touch. And then it touches here and goes back up. Same thing here. And again, it sort of has an anti-amplitude. There's going to be definite space in between where that function does not exist. And the same thing for cosecant in this case, which would be between 1 and -1. There really doesn't have any graph, right? There isn't any graph for that function. That's anti-amplitude. Notice the period is still 2 pi because sine's period and cosine's period was also 2 pi. Okay, so when I start to do transformations of those, and we'll do these three here. When I start to do transformations, still think about sines and cosines first. So when you see cosecant, when you see cosecant, you should be thinking, the sine function first, right? So let's think about what if this were the graph of 3 sine of 2x. So 3 would have had a height of 3 for its amplitude on the sine function. And then the same thing going down here. So we can get the sine function. So we're trying to, again, base it on what we know. 3, -3. We're drawing our dotted line to represent its sine function. And then we're going to look at that frequency of 2. Right? So same thing, the frequency of 2. So 2 pi divided by 2 means our new period is pi. So I should label this pi, and then I quarter that off, so that's pi fourths. This is 2 pi fourths. This is pi halves. This is 3 pi fourths. That's 4 pi fourths or pi. And then at least we know this is negative pi, and this is negative pi over 2. And then what we'll do is we'll draw vertical asymptotes. So wherever it crosses the 0, that gives rise to our vertical asymptotes for this cosecant function. And then we just draw in the u's that touch the tips and the valleys of the actual sine function. So we get these disjoint u's and n's that are bound by these asymptotes. Now, because they're bound by the asymptotes, these are not parabolas, right? They are simply boundaries, and so these, again, they start to approach vertical lines. So the graph itself is, in fact, in this kind of purpley color. So I can make it a little bit darker to really highlight that here. Okay, so let's do the next one. I'm going to first think about that as a cosine graph. So I'm going to think about, instead of secant, I'm going to think about it as cosine. And then it becomes like amplitude of 2. So I have a 2 up here, 0's here, -2, 0, 2. And again, I'm going to draw that as a dotted line for cosine. Okay. And then our frequency, right? So it's 2 pi. So it's 2 pi divided by pi over 2, which equals 4. So I know that this is 4. And then I quarter that, so that's 1, 2, 3, 4. And same thing over here, -1, -2, -3, and -4. Now that I know where it crosses, let's go ahead and draw the asymptotes. Draw the asymptotes where it crosses, right, where the x-axis crosses. And then our last bit is to actually draw the U shapes in the ends. I'll make them a little bit thicker so I can really distinguish that. And that's the thing. You're going to want to make sure that you do distinguish this on a quiz, on a test, homework, etc. Now, one thing I forgot to mention is that the secant function, like, it kind of, like, right, the way it starts and ends, it starts on half of a, right? It starts with half of a branch, and you get the other half on the other side. So, from an aesthetics point of view, it is centered on the y-axis, right? Because it is an even function where the other, like the cosecant graph has full, full of the u or the n's, but it's not centered. It's an odd function. So I just wanted to reference that. Okay, last one, and then finish up this video here. So the -1 acts just like the -1 did in a sine or cosine graph. So I'm going to just draw the new line of equilibrium coming down here. I'm a little bit on low battery, so I think I should be able to finish. And an amplitude of 2. So I'm going to start here, go up 2, go back down to here, go to -2, get back up to here. So again, we're just graphing the sine function because we're thinking sine. And we're thinking the sine function. So we'll just draw that dotted, draw that dotted, draw that dotted, or a different color or a lighter color. And, I don't mind seeing this. This is your work, right? Now, our frequency, so 2 pi over 8. So 2 pi divided by 8 is a very fast frequency, which means it's every pi fourths. So this marking out here, I'll mark as pi fourths. And then we quarter that, so that's pi 16ths, 2 pi 16ths, which is pi eighths, 3 pi 16ths, and then 4 pi 16ths, which is pi over 4. So this is negative pi fourths, and this is negative pi over 2. And then we want to draw our asymptotes where it crosses this new line of symmetry. So again, we're basing it on that line of equilibrium here, line of equilibrium here, same thing here and here. And then we flip up our actual graph. So maybe I'll make this in a darker orange and a little bit thicker. Okay, so, and again, it's important to make them touch. I didn't realize that was the asymptotes color. Make them touch. And then same thing here. Now, one thing I noticed that I did not label was my vertical axis. And I guess my assumption is that if there's no label there, it's assumed to be 1 unit. But just to draw emphasis, I could say that's a 1. And down here is -3. So I really emphasize that anti-amplitude. Okay, so again, just kind of sketching the behavior of that. And then obviously we'll have more practice questions with phase shift, but at least wanted to get a start on that. And I'll post one more video that will just kind of walk us through how to make sure we know how to get the equations given the graphs.